Okay, so my name is Rubén Lozano. I'm currently a product manager at Google Cloud. I'm overseeing the customer experience for all the online experiences before customers actually start using the cloud. And I'm currently trying to build a team of product managers. And before coming to Google, I was at Amazon, and I was managing a team of senior product managers, technical, in search, and I was there for around 3 years. And most of my talk actually is going to be about my experiences actually at Amazon, but I will give you some hints as well from Google as well. So this is what the agenda of the day will be, is just what is ML. A lot of people from the audience already are familiar with what ML is. I'm not going to take a lot of time here. I just want to make sure that at least the vocabulary is understood. The next part is, I think that is one of the most important ones, is, well, how can you use machine learning? Like, should you use machine learning for your problems or not? And really to understand when is a good use of machine learning for your specific problem that you want to solve. Then I'm going to go into a very high overview about the process of using machine learning to resolve a problem. And then I will take a little bit more of time and really go into details about what is the role of a product manager in machine learning. And I think that this is something that through my experiences at Amazon, that was very important, because sometimes people didn't really understand where the boundaries were between different roles, and it's important for you, as if you want to become a product manager, what's your role and how can you help the whole team? You're always a part of the team as a product manager. And last, just give you some overview and some advice of my experiences when I've been working with product manager, with machine learning and data scientists, that may be helpful for some of you as you start your journey in machine learning. So first, what is machine learning? So machine learning is just a subset of artificial intelligence. And I mean, artificial intelligence is just basically like when a machine is trying to mimic what a human is doing. And machine learning uses a lot of statistics and algorithms to actually kind of mimic what a human will be doing. And deep learning is another concept that comes a lot with machine learning. And just for you to get the general idea, just think about deep learning as maybe multiple layers of machine learning. And that's the only thing that you really need to understand. Right now, we're going to be focusing specifically on machine learning, how these statistical concepts can help you solve problems. So this is the actual definition of machine learning, the study that gives you computers the ability to learn without being explicitly programmed. And that's the key, like the key to open so many doors that didn't exist before. And that's why machine learning could be super, super helpful, because in many circumstances, in the regular classic programming, you need to have very specific rules about what you want to do. And you need to know most of those things beforehand, right? And there are many, many problems that you can solve with classic programming, right? You say, I don't know, like, specifically for Amazon, if you are a Prime customer, maybe you want to show some specific features for them. If you're not a Prime customer, you show something different. If you're in a specific place in the world, you show customers different features, or you change or you customize the experience based on these specific rules. And these rules can be more and more complicated. And you have some data to help you do that. You code all the rules, and then you have your answers. And that's great. The interesting part is when the rules are just too many. And the classic example that I will be using a lot here is search. I was working at Amazon in search. So how do you use rules for search when you don't have thousands of inputs, you may have unlimited types of inputs of queries and words of things that people can do. So how can you actually create experiences that will be adapting to how people are using this? You may be able to create some rules but that may not be the a scalable way to do it. So the interesting part with machine learning is that you use machine learning when you actually have, when rules are not exactly like, you don't really know the rules, but you have a lot of data and you have a lot of answers. And this is key because machine learning is not magic. And something that you as product managers, you will see is when you go to a business meeting and you're meeting with people who are not very familiar with machine learning, they will just say machine learning as a magic wand, right? Like, we have a problem, we don't know this. Let's use machine learning to understand what it is. And you're like, I mean, if you don't understand what it is, like, machine learning is not suddenly going to give you the answer. And I think that that's the key difference. You can only use machine learning when you actually know what is the answer that you wanna get. This may be a little bit confusing, but we will go into more details about that. The way to think about this is, as a product manager, always think about what is the problem that you wanna solve. With machine learning, the first thing that you need to know is, like, do we have data? And do we have enough data? We will go into details about what is enough data later on. But if you don't have enough data, machine learning is not your solution, right? One of I was talking with some people from the audience here to say that at some point I got used at Amazon that we had so much data. So machine learning was pretty much an option in many of the circumstances. In my current role at Google, where we're looking into something completely new that no one has used before, and we don't have data. So, like, okay, for all these experiences, like, how are we going to start using machine learning if we don't know, if we don't have the data about, like, user behavior? We don't really know what people are going to do or what do we want them to do. So suddenly you start saying, yeah, we have a problem, but we don't have the data, so maybe machine learning may not be the issue, the solution, but in some circumstances it will. And after that, you start thinking about, well, based on the data that we have and the problem that we want to solve, what is the right algorithm to use to potentially predict the answer that you want. And this is where data science and scientists will start joining you to be able to figure out what is the right algorithm to be able to create the right model and at the end the right output or prediction in machine learning. Something that I like to do, for at least for me, and hopefully for you will be helpful, is how we can use statistics as a way to kind of compare how does it fit with machine learning, because some of the concepts are very, very similar. It's just that sometimes I would say the vocabulary that people are using is a little bit different. So maybe let's tell me, are people familiar with statistics here? Basic statistics? Kind of. But in general, when you, let's say in statistics, when you have your dependent variable, your y, right? The output variable, basically, the thing that you're trying to predict. In statistics, it's called like dependent variable. Output variable in machine learning is usually called a label or a target. But it's kind of the same. Is what you want to predict is the answer. The data that will help you make predictions are these independent variables in statistics that will be called features in machine learning. When you're basically trying to get all your data in the right place, basically reshaping the data to get the most out of it, usually it's called data transformation in statistics. In machine learning, it's called feature engineering. And basically, when you're trying to figure out, you made a model in statistics, and it's very clear that from all your statistics professors, basically they're telling you, don't use a lot of variables. Even if you're creating a model with like 200 variables, try to figure out which ones are not the ones and just select the ones that are important, because it will make your model way more solid. That is like the subset or variable selection in statistics, and in machine learning is feature selection. So my main goal here is like you get comfortable with these terms, because I will start using them more when I'm talking about a feature engineering, feature selection, labels. It's very similar to statistics. As I said at the beginning, machine learning is just using statistics to create this, to mimic what humans actually do. There are two main subsets of machine learning. This is very basic: supervised learning and unsupervised learning. I'm not going to go into a lot of details here. The only difference that you need to understand for this talk is that supervised learning, when you are looking at the data, you have to label that data. You actually need to recognize what the data means, and you need to have, for example, if I want to, in my examples for Amazon, if I want to predict or to provide a recommendation to a customer, I need to have like an order, and I need to understand, is this order successful or not successful, and I need to label that beforehand. And with unsupervised learning, basically you're using data that you don't really, you cannot really label, and you're trying to use machine learning to actually understand the similarities between the different data. A good example is when you want to figure out what are like customer segments or cluster things that are very similar, that you may want to say, well, I don't really know if this is similar to what, right? Like, I just want to know that two things are similar, but you don't really know how many things are. This is confusing, but it will get better, I'm telling you. So the next part that I think that is the most interesting is like, when should you use machine learning? As I started at the beginning, machine learning starts with data. You need to have data. If you don't have data, choose another solution, really. But if you have data, that's great. And the cool part about machine learning is that it's a cycle, and it could be a virtuous cycle. If you have a lot of data and really good data, then you can potentially do really great predictions. And if you do really great predictions, you will improve the customer experience. And if you improve the customer experience, hopefully you will get more traffic to whatever product you're building. And when you get more traffic, you will get even more data. So that's one of the I would say pillars of using machine learning. Again, think about data. Do I have the right data or not? And based on that, a lot needs to happen. So how do you analyze a problem and figure out if you can use machine learning or not? So I'm using this framework. I use this framework a lot in my work in search to figure out, should I use machine learning? And the first one is that, is my problem handling very complex logic? And I'm really trying to figure out that it's complex, right? If you can solve whatever problem you have with rules, with if statements, even if there are like 20 if statements, use it. Really, because it's going to be a little bit, machine learning is complicated, it's a complex process. So really try to figure out if you have a problem that is very, very difficult to solve with rules. The classic examples of like complex logic could be if you want to, let's say, with search is a classic example, right? Like if you have a lot of different keywords, you cannot have rules for different keywords and figure out what are the results. But that's the first one. The second one is that if your problem will be scaling up really fast. You may have a problem that it's pretty complex, and you say, well, that's great. I'm going to do a machine learning solution for this problem, but it's a small problem. Like your customers are not going to be too many. You're not going to be using it a lot of times. Is it worth to go through that process? Or is it going to, or are you thinking about something that is going to just simply there's a lot of opportunity if you automate some of these problems, because you may be able to save labor, for example. If you have, for example, some people, let's think about this example that I'm going to use later, but at Amazon, how do you know if, for example, a fruit that are you sending in Amazon Fresh is effective or not? if you're starting the pilot with Amazon Fresh, that process is complex, right? Like, how do you know if it's good or not? But are you going to build a machine learning process when the number of orders that you have are like 100 per day? No. But if you start thinking that, okay, this is going to scale, and actually I'm going to start not having 100 orders, but I'm going to have 1,000, 2,000, you're like, yeah, maybe it's time, right? So think about that. Think about like the scale of the problem. Is it going to be worth it? The next one is if it requires specialized personalization. Again, this you will see it in most of the new services that you get, like with Facebook, with Netflix, with Google, with Amazon. If you really want to provide a specific answer to a specific person for something that they did specifically, yeah, I mean, the rules are going to be too complex. It won't make sense unless you use machine learning. But again, if you can actually reduce the complexity and say, I have 5 customer segments, I have 10 customer segments, that's easier. And the other one, and I think that's one of the most important, is your problem going to be changing across time. So if whatever problem you're trying to solve is very, how do you say, it's not going to be changing from today to next year, you may want, and it's not very complex, you may not want to use it. But for example, let's say that you have a problem that it's very complex, it may not scale up really fast, it requires specialization, and you know that it could change from day one to the next one. And again, I'm using search as an example because trends can happen, right? So if suddenly today Beyonce releases her new album, people are going to be searching for that, and you want to make sure that you can adapt. And you can adapt immediately. So if one of your problems is something is going to change suddenly, and you want to make sure that you catch that trend, machine learning is a good option. Because if not, your rules are not going to work. I'm going to give you a pretty interesting example from one of my first times at Amazon, where we actually had a rule for a keyword that it was ring, because the way that our machine learning algorithm was back in the time, it was not great. There were, like, when people were using ring, the results were not amazing. And at some point, we're like, you know what? This is a very difficult problem to solve right now. What we're going to do is, like, when people actually write ring, we're going to redirect you to our rings, to a page for jewelry, where you can see all the rings, and we can optimize that experience, and it's much better than the simple search results. The problem of having that rule is that when the Ring doorbell started to become popular, people were searching Ring, and we were redirecting them to the jewelry place. And every time that people were trying to put Ring, we will redirect them. You're like, no, you can't put those kind of rules in search. And the most important part, you actually need to have answers. As I say, in machine learning, you have all the data, and you really need to understand what is a good result, right? In my case of Ring, I know what a good result will be. It will be, if I'm searching for shirts, I want to see shirts. If not, if I were searching for dresses, I want to see dresses. So you need to have like a good, you want to know. You need to understand your end result. You don't use machine learning for a problem that, let's say right now in Google Cloud, I want to understand like what's the most, the best, the easiest API that, or the most, the API that people learn faster. And I'm like, well, I don't know. I mean, I don't know, how are you going to know how is learning faster? What does that mean? You have to specify everything, but maybe machine learning is not the right answer for something like that. So I'm going to go through some simple problems, like for you to understand the different problems that machine learning uses, so maybe you can relate them a little bit more. The first one is ranking. It's just basically helping people find the most relevant thing. That's a great that's a great use of machine learning. So the classic example is a search for Amazon, for Google. You don't have a formula. It's very, as we were saying at the beginning, does it handle complex logic? It's like, yeah, it does. Does it scales? Yes, it does scale. Does it change through time? Yes, it does. And so this is like every time that you want to rank something, machine learning is a good example. The interesting part here is that I think there's a misconception that a lot of ranking is done through formulas, but the problem is that doesn't scale, right? Like how do you know, like if it, in the case for Amazon, how do you know that if it's prime, like does it have the weight, how much should it be if you're prime and the product is prime, if the product is going to be, how do you say, if it has good reviews, if it's cheap, if it's whatever. If you start using all those variables and try to create a perfect formula, I mean, you're doomed, right? It's not going to happen. Recommendations. That's another great use of machine learning because you give users the thing that they may may be interested in. Again, this is something that is used, again, a lot of at Amazon, is using recommendation from Netflix, is using past experiences and trying to predict what is the specific outcome based on specific variables. You can use it in Google Calendar that is trying to predict like what room you may want to set your meeting based on like previous times that you have set your meeting or where you are. So it's using multiple different variables to try to predict an outcome and saying, we think that this is what you want. We're not completely sure, but we think so. And this is actually very important for you to understand that and we'll go into details later, that machine learning is not always perfect. So if your solution requires like 100% accuracy, maybe machine learning is not the best. But if in this case you're recommending something and it's not great, it's like the world doesn't end. The next one will be classification. And this is where we were discussing a little bit about supervised and unsupervised. Think about classification still as supervised learning, where you're trying to use machine learning to classify different things. Something that we used a lot at Amazon for machine learning classification was the catalog. There are billions of products at Amazon. When different vendors are putting them in the catalog, they specifically say what kind of product is this, right? Is this a dress or what kind of dress? But they may be wrong. So, or maybe they're wrong on purpose for other reasons that I'm not going to discuss here. But you can use machine learning to go through all your data and your catalog and say, is this, maybe let's use the image and trying to figure out if that image actually matches the information that is in the catalog. And as we were discussing before, that's, even though the logic may not be super difficult, the scale is so big, right? Like when you're talking about millions or billions of products, and even if the problem is not very complex, it's a good use of machine learning. Another one is regression, and I think, again, this is based on statistics, right? Machine learning is based on statistics. So if you want to predict the outcome or something in particular, in this case, it's a lot about forecasting. If you want to understand like how much a product will be sold, of course you can have like a specific model that can predict that. But what happens when your products keep growing and growing and growing and growing and growing, and the behavior of the people, as we were discussing on the time, could change drastically from one day to the other one? How are you going to know that your actual forecasting model are going to adapt to that? If you had a forecasting model for something, and yeah, maybe you are considering seasonality, you're considering out of stock, you may be considering different promotion for marketing, but if you don't consider like there was a scandal in the media about something, you will be doomed as well. Another one is clustering, and clustering is something that unsupervised learning will do very well. That is when you want to just cluster things that are similar to each other, but you don't really know what they are. So in this case, a good example to visualize this is at Google search when you are going into news and you're starting getting all these news that are related to each other. So it's trying to figure out like, well, you found something, let's figure out what is close to that, what is clustering that specific point in time. And the other one that we discussed, an anomaly, that is trying to figure out what is different from the rest. I really like the example of the fruit freshness because it seems to be very simple, but at the same time, it could be big. And that's something that machine learning can help you decide, is this good, is this not good? And at a scale, it's very important. This one specifically, right, if you start thinking that a human can actually do it well for strawberries, that's great. Then you have to do it for bananas, and then you have to do it for pears, and then you have to do it for everything. And then like the skill set of people doing that job may not scale as easy. While some of these models, while at the beginning it could be very complicated or complex to create them, they can scale so much faster. So we talk about like a couple of problems that machine learning can use. Yeah.
I had a question on the last slide.
Yeah.
What's the difference between anomaly and classification? Like, is it very different or? In
classification, you're basically just trying to, it's similar, right? Like classification is just trying to say like, does this match this? Does this match this? Does this match this? An anomaly is just like, is it different from something?
But it uses the same techniques, right?
It could be different depending on like there are some how do you say, there are some models that will be better used to do anomaly and others for classification because that's the main difference, like the type of model that you will be using.
Would the critical difference be for classification for the fruit example? You would need data labeled as being fresh or not. Whereas with anomaly, you could just give it unstructured data and assume that the anomalies are the not fresh fruit. So you don't have to go through the annotation effort.
You do need to tell the model what is fresh and what is not. You could only see like something that is different. So you could use anomaly to say, is it a strawberry or not?
Right.
For that one,
what if the anomaly was that it's not fresh?
If it's not fresh, you have to label it. Like, how do you know if it's fresh or not?
Deep learning, you don't have to know.
That's another way of doing it, right? So in general, we talk about the problems that machine learning could solve, the framework that you could use to see, like, is my problem worth of doing machine learning? We'll look at some of the different problems that you can use. But let's go back to the data. And the first thing that you have to think is like, can you use this data, right? Do you have access to this this data? Is it available? Sometimes you will have a problem where you simply just don't have the data. So think about having it. Another one being accessible. When you're working with all these humongous companies, that's critical, right? You may have all the data in the world about billing and customer information, but like you may not have access to it, and your model may not have access to it. So yeah, you have this great problem, but you can't access the data. So think about it, if you can use it. And the most important one is like, should you be using this data, right? You may have all this data about billing information about customers and where they live, what have you. Is it a good use to use this data? And I talk people about like the creepiness factor. If you start thinking that, I don't want this to be in the news, it looks kind of weird that we're using this data to actually do something good for the customer, but people are not going to feel okay that you're using that data, maybe don't, right? So not because you have the data and it's accessible and available, that means that you should be using the data. Respect privacy and make sure that whatever data you're using, all through the process of all your different pipelines is actually secure. You don't want that data to ever be compromised. So if you don't have a system that is secure to put your data and to create your models, I mean, be careful, right? And is it high quality? And this is very important, right? I'm talking about like being relevant data. You may have a lot of data that is not actually relevant for the problem that you're solving. So understand that. You may have if you have fresh data, that's great. Like what I'm talking is like data that you can use to actually solve that specific problem. You may have a lot of data for, I don't know, suppose that you're launching a feature for a specific product, and that feature was launched 3 years ago and it didn't work. And you can say, hey, well, we have a lot of data of how customers use it like 3 years ago. We're going to use it. The behaviors could have changed completely. So if it's not fresh, I will really recommend not to use it. The other one that is representative, right? Really think about your problem. If you're trying to, if you're trying to, for example, solve. This was a classic example, like when Amazon was moving to different marketplaces, right? If you are in the US and we're launching in Mexico, yeah, we have a lot of different data from the US. Is it representative of how people in Mexico buy things? Like, you have to really think about, like, can we just reuse this data or not? Like, what are the patterns? And the other one that is one of the most important one that it should be unbiased. And there's so many biases in machine learning that I will talk about that later. But again, like, is the data that you're capturing really capturing what customers are doing, right? Like, suppose that you want to build any feature, but the only data that you have is for like logged in users, because for like people who are unrecognized on your site, you didn't capture that data and you don't have it. But the feature that you're actually going to be using is going to be for all. Well, that is not representative, right? And it's also going to be biased. So again, I think that this is exactly the same that I said before, but the opposite, just to make sure that we're on the same page. So don't do ML if your problem can be solved by simple rules. If it doesn't really adapt to new information, if it's always the same, this is the other part. If you want to always have the correct answer, machine learning is not your solution. A good example, again, that I would tell, or it's not the only solution, you can use it as a step before the end solution. So a good example is that at Amazon specifically, Amazon needs to, when you're sending a package that has a flammable product, you have to put a specific label, right? You maybe use a machine learning algorithm to kind of figure out which are those products. But if you don't put a specific label to one of those products, like Amazon will be fine with thousands, like hundreds of thousands of dollars. So if you want 100% accuracy, maybe machine learning is not the best. And the other one, like, requires full interpretability. Are you okay with not exactly knowing why something happened? And that's big, right? And that comes from recommendations, from search, for all these things that people say, hey, this is what the machine learning model said. I want to know exactly what happened. You may be able to give a kind of idea of the variables, of the features, but you don't really understand 100% why it happened. So if you are doing any kind of process that you need like full traceability about everything that happened and how it influenced that decision, like for legal purposes, whatever, machine learning may not be the best as well. And again, if it's not available, if it's inaccessible, it could take you months to even get to that stage. So really figure out, like, is it in my timelines for my product? If there are some privacy concerns, if it's not secure, really don't even try. And again, right, like when you have this irrelevant data, stale, bias, everything starts with data. If you don't have the right data, then there's no point to go ahead.
I have a question.
Yes.
What is the definition of high quality for a regression problem?
Well, it will need to be specifically to, well, like, what, do you have a more specific situation?
regression is more on numberings, right? Like you showed.
Yeah.
What is high quality data in that sense? When we say you can use ML if your data quality is high.
Yeah.
So how do we define? I mean, can you explain more on that?
Yeah, I mean, for example, if you want to say, are you doing regression and a forecasting to produce, for example, how many products should I buy from phone cases, right? Do you have, number one, do you have enough data about like how many, for example, like how many orders have you had during the last year, right? Do you have enough information, for example, if you want to do the forecasting like in the whole United States, do you have information for each one of the different places where you're going to have like fulfillment centers? Are you making sure that you're getting the data when you actually had the products? Maybe at some point some of the vendors were out of stock, so if you got the data from like, for example, if you get the data only from the holiday season and you use the data for the holiday season to predict or to forecast, and that's the only one that you have to forecast for the whole year, that's not high quality. And even, it's just, you have a lot of data, but it's just for a specific part, so it's not representative and it's unbiased, even though you have enough. So I'll do a simple exercise just to see if you were paying attention. So the first one is like, let's see if you want to ML or not to ML. What apparel items should be protected by copyright laws? Yeah.
Yes.
Yes? Who said yes? Why?
So if you didn't copyright, you're saying you would lose a lot of money, and that's why you're saying no?
Yeah. When it's a rule where you're going to have, like when you need 100% accuracy, it's not the best. Something that you can do is just to use that to simplify the problem and then you do a review. But for that one, you have to be very careful that your model is, we will look later, how do you validate the success of a model? If it's the precision and recall. So if your recall, if your recall score is low, I wouldn't use it. Because you don't want any product that is not, that you should be copyrighted not to be there. The next one. Which resume should we prioritize to interview for a candidate, for the candidate pipeline? Yes, no? Yes? Yes?
No. And I know Amazon did that. And I know Amazon did that.
Yeah? This is when things starts to become interesting, right? Like you can say it is a complex problem. It changes over time. It scales a lot. So it actually has all of the qualities of being a great candidate to be for machine learning, right? We have all the data. We may have a lot of quality data, but it's biased, right? Like you only have the data of the candidates who apply and who made it, right? You don't have all the data of people who were great that never applied. You don't. And that's it. Like you have, you will be making the same mistakes that you did currently. So you will never get better, right? Like the joke at Amazon is like, if we do this, everyone is going to be called, like everyone who joins Amazon will be called Jeff. So what products should be exclusively sold to Hispanics in the US? Yes, no? Who said yes? No one. So no? No one. I mean, this is very tempting, right? Because you may have all the data to actually say, oh, a lot of people who fit this profile and they have this behavior and they actually buy these things. like it's very tempting, but it's not. It's discrimination, right? Like you should not do it. Because you never know, right? Like you're basically making a lot of assumptions about people, and you shouldn't. Which sellers have the greatest revenue potential?
Yes.
Yes. Yes.
Yeah, that's easy. A lot of people will say, well, it is discrimination as well. And the interesting part here is like, how are you going to be using this data? So at Amazon is like, well, you're always trying to help sellers to be better for customers, and you have limited resources, so you cannot help every single seller. So you need to find a way to decide which sellers to help a little bit more. And it's okay if you miss some sellers that have a high potential, or you have like some sellers that maybe were not great, but that will help you a ton to be able to use your limited resources.
Sorry, I just want to clarify. See, when you say discrimination, you mean the data we have is biased, or you mean the problem itself is a discrimination?
The problem itself is
So
discrimination.
it doesn't matter whether you use machine learning or not.
Correct. Yeah.
Okay.
But that's the case, right? Like, and I can tell you, like by experience, like people will come with ideas to say, should we do this? And you're like, no, we shouldn't. And they're like, but we can. I'm like, yep, we can, but we shouldn't. And yeah, it could be a great problem. I mean, it fits. It's not the right thing to do. Where should Amazon build HQ2?
Yes.
No.
Yes?
Yes.
No.
Who says yes? Couple. The issue is that this is not going to be a repeatable problem. So what's the point of going through everything all the variables? It may help you. Like, what is the answer? You don't have answers. I mean, you have Seattle, right? That's it. So that, again, machine learning is not a magic wand. It's not going to give you an answer on data for something that you don't know.
Give you the top contenders, things that you should look at for.
But what data do you have? You have Seattle, right?
You have people who are computer science graduates. You have people who are working in good companies. You have people who made it to certain interviews.
Yeah, so you can use all of that to create rules and actually create a program that will, based on all these rules, and you just input them and it will tell you. But you don't have to go through the process of creating a machine learning model, because like the cities, it's not something that, it will be different if you're thinking that I'm a Starbucks and I'm going to be opening new franchises, right? Like, and I want to open new franchises like continuously. I don't know if it will helpful, but that's something that I'm saying, well, things are changing, it's a complex problem, you're growing, maybe, like it may be interesting to see if things change, right? But for a decision that is only one time, maybe not. And you'll also have, like for Starbucks franchises, you will have a lot of data from how they differ. So this one is like, which search query should we scope for the Amazon Fresh store? This is very specific. Yes, and obviously this is a combination of machine learning and regular programming, because you can make the process way easier, right? And I was actually in this team that built that when Fresh was starting. And we were like, well, if you are searching for a banana, or not for a banana, let's say Nutella, where should we put you? In the regular store of Amazon, on the Amazon Fresh store? Where should we put you, right? And at the beginning was like, well, if you have a Fresh membership, we should put you in the Fresh store or not. You start like having, we can have certain rules that we can apply, and then your data will be a little bit more, will be better, and then you just use that data to actually improve your process. So you can use combination of machine learning and regular programming for things. So, okay. So any specific questions? Yeah.
Just the example you gave, so the data you have is based on the rules you previously set, right?
Yes.
I'm just trying to understand how is that different from bias data.
It's always a little bit biased, right? But again, so for example, in the case for Amazon Fresh, something that was super interesting is that we have the fresh.amazon.com homepage where we had a lot of data about people who were buying fresh there. But then we had to integrate it with all the information that we have in Amazon.com. So we had some data. It was not perfect because one of the main things is like if you are in fresh.amazon.com, you are in your mindset that you are in fresh.amazon.com and you want a fresh order. If you are in amazon.com, you may want to be in fresh or may not want to be in fresh. So it is a little bit biased. So then we have to be very careful to say what kind of, how do you say, what are we okay? Like what is our threshold for mistakes? And we experimented, but that's a completely different thing, right? Like what we have to say, well, we believe that we can have a better experience if we use this data with a specifically machine learning model for fresh, we call it like fresh autoscoping, to be able to decide if you're ordering like milk or banana, if you're searching for milk, banana, whatever, we send you to the right specific spot. And then we figure out is it good or not, right? Because at some point, whatever we are deciding that's a better customer experience may not be correct, right? So something that at Amazon and at Google and most of these companies will do is like everything that you're doing, you need to actually experiment and figure out if it's good or not. So that's the next level.
Will you be talking about imbalancing data sets?
Yeah. I mean, not only that, but for example, one of the problems, like we had tons of problems in that specific circumstance because not all the products that were in Fresh were in the Amazon.com. In Amazon.com, we had the categories were different. So even like when we wanted to scope people in a specific like search result page with specific filters that were different from Fresh, so we couldn't do actually the same kind of matching. So then we started to say, oh, we can only do it with very high confidence. So it was a very subset of queries that will say, for this subset of queries with this confidence level, for all of this, we think that the experience is better. But the good part about machine learning is like it will start learning, right? So the model will keep getting better and better and better and better. And eventually it got better, right? So let's do machine learning, right? So what do you need for machine learning? There are three main things. You need people, of course, processes. You need tools and systems. And actually, all of the three are very important. If you don't have one of them, very likely you may not be able to do machine learning, even if you want, and even if the problem is great. So the first thing is get the right people, right? There are many different roles in different organizations. I guess that all my text is a little bit off. But the part that I think that it's important for us as product managers, or people who want to be product managers, to understand is just to differentiate science or math through engineering. It's not actually the same. So think about all the people who are doing all the research scientists, data scientists, applied scientists, ML scientists, depending on the company, they're called differently. They're looking into all the math, like what is the right model, what is the right way to look at the data and to figure out like what is the variable, like what are the thresholds, etc. But they're not actually doing the engineering. And what I talk about the engineering is how are you collecting the data? How are you cleaning the data? How are you going to make sure that you're processing the data? How are you making sure that is correct? If you had a model and then you have to, for example, you may want to update your model and all of your data every day. I mean, a data scientist is not going to be that engineering work. That's going to be an engineer who will be saying like, what is the data? How do I collect it? How do I rank it? How do I access it? So think about those two. There are some people who can do everything, but just be aware of the difference. Okay, so what is the process? So first, and the most important one, is to formulate the problem. And this is, I'm going to go through this really fast, and then I'm going to go into review it again, but with the lenses of a product manager. So I think that will be a little bit more helpful. So stay with me as I'm going through this, and then we can go, when I go into the product management review, then please ask questions. So as I say, the problem is the most important part. We kind of understood what are the things that you have to think if your problem is the right one for machine learning. Make sure that it's super clear what you wanna solve. What is the measurable goal, and what do you want to predict, right? As I say again, like machine learning is not magic. You really need to understand like what exactly do you want to predict. How do you know that it's going to be successful, and what is your problem? We're going to go through examples later. The second one is, again, data. For data, just think about like the importance of selecting the data. First is like, what is the data that is available? You need to understand what it is. Okay, this is what it is. Then you have to figure out what is the data that you're missing, right? There's a lot of times where that part is critical to know if you're actually going to have a good machine learning model. When we were talking about the fresh example, like, yeah, we have a lot of data of products that we're selling in Amazon.com that we're not selling in Fresh.com. So we're missing a lot of data there. So there are many techniques to figure out what to do when you have missing data. But first, it's like selecting the data, understanding what is the data that is missing, and then discarding. That's the part that a lot of people don't like to do, but you have to remove as many data that is not important. And people will be like, well, but it may, like, no, remove it, like really remove it. And because if not, your model is not going to be okay, right? And that's, how can I say this? This is sometimes a big issue when you're dealing with different business teams, because they will come and say, but we have all this data, and you start to like basically find all the problems, and you're like, yeah, but your data is not there, and this is not okay. But people say, come on, like you were asking me for like 5,000 records, here they are. Like, why are you like making things harder, right? But you have to know that you're not going to actually do a good prediction. And you need to communicate that, right? Like, and why this is not a good prediction. And if after you discard things and you get like very little data, and sometimes it's data that you cannot use, right, for privacy concerns. So think about that. And then the next process is like, okay, first is the problem, go through the data. Do you have the right data? Do you understand which one is the one that you want to use? And then you have to do the pre-processing to really try to select the, when you're getting the specific data, what specific parts of the data are important, right? Like it could be like just formatting the data, just to, I mean, as simple as lowercase, making everything in lowercase could be something that you need to do, an engineer need to do, like when you're collecting the data. Just cleaning it and sampling it. We're going to go into details about how you as a product manager, what role you play in those parts. The next one is features. If you remember what I talked about statistics, these are the variables that you're going to be using. So basically, yeah, the variables that you're going to be using to make your predictions. So there are three main different ways to basically to do feature engineering. The first one is called scaling. That is basically just making sure that all of your data is in the same format. Like if you're talking about currency, that's a classic example. You're doing a prediction. So you want to make, and you want to look in sales volumes, whatever, like just making sure that all your quantities are the same, all the methods that you're doing are the same. Then the next one is decomposition. A good example for this is that suppose that you have a timestamp. What part of the timestamp is important, right? Is it the day? Is it the hour? Is it all together? And try to be, try to discard anything that is not relevant. The more data that you start using that is actually irrelevant for whatever you're going to be doing, it's going to create more problems. So decomposing, and then aggregation, that some of the data, it's better if you're aggregated, right? So you already have, just to understand again, all of this is already clean data, right? You have data that is already available, that is good, that is great, that is high quality. But now you have to do the feature engineering that is, okay, now I have all this great data, how am I going to actually use it? So the formatting, the cleaning, the sampling, the aggregation. The aggregation could be, a good example will be, you may have logged in, you're trying to improve the customer experience, but you logged in at Amazon through your laptop and your phone. Do you want to use those as 2 sessions or 1 session, for example? You're like, well, depending on the problem that you're going to be solving, sometimes you may want to say, I want to see this by user, or I want to see this by session. So all the data is clean. It's a matter of like, how are you going to be using it? And the last one is actually doing the model. For the model, again, you have this data set. It's already clean. It's already good. It's formatted. It's sampled. It's perfect. The first thing that you actually do is you have to divide it. And you divide it in what is called training data and what is called test data. The way that you usually think about this is that you need, there's not a formula to say like what percentage of data should be training, what percentage should be testing. But usually you need a little bit more of training than testing. So depending on the problem, you may go into 70-30 or 90-10. It varies. But the main point is like you use all your data that you have. You use a certain amount of that to actually train your model, create your formula, whatever. And then after everything is done, you actually use your test data to put it again in your model and to see, oh, does it predict the thing that I want them to predict? You don't want to use the same data that you used to train it because obviously it's memory, like you already know what is going to happen. So I said you have the data set, you divide it, you just use the training data with all the features that you said that you're going to use. You have this model training. You don't need to understand this part right now. That is basically the algorithm that you're going to be used to predict the outcome. And this is when you start saying, oh, is it an anomaly? Is it a clustering? Is it whatever? That actually will define the kind of model that you will be using. Then you have the actual outcome when you kind of have the weights of how each one of the features will be valued. And then when you have all that ready, then you use the test data, you put it again in your model and figure out if the output is what you were expecting or not. And then you have to obviously test it. So we will go into that into later. After you do that process, then you have to productionize your model. It's important that you understand that you require a deployment environment to have machine learning. You have to really understand, for example, if you're accessing data, and can you do the training offline? Do you need to do it online? Again, like how often are you going to be reviewing the data and training the data? It is something that changes very fast. If you want to change it very fast, maybe your model needs to be like updated daily or hourly. So think about like, do you have the right environment to actually do that kind of processing? Then where are you going to be storing the data? And this is important. We discussed security. And I just want to make sure that you don't forget that. And how are you going to be storing the data in terms of what type of database you're going to be using, if you can compress some of the data because you only need like the output. You just need, like, most of the engineering, like your engineers will be able to figure out if this is if what is the right solution, but that's basically where they come in place. And also this is very relevant, like monitoring and maintenance. How do you know that your model is working, right? Because that's like we discussed before, right? That you don't actually know the full interpretability of the model. So if you don't really know how something is working with a formula, then how do you know that things are not just going crazy? So you need to create some kind of monitoring tool, deployment, or something that is going to tell you that things are not, that are actually okay. And that's how can I say this? Like, a lot of the times, this step is not taken into account, and that's a problem, right? Because you can have a machine learning model that is just getting worse and worse and worse if you didn't do it correctly. The other part is that there are, I don't want to be, I think that I'm only saying not to use machine learning in this session, but there are many options where the problem is great, the data is great, everything is amazing, but it's very costly. It just doesn't make sense to actually do it because the actual outcome that you're going to get is not worth it because maybe your model needs to be updated hourly, and you need a lot of data to actually do that, and it's just not worth it. So as any other part with product management, you really need to figure out what is the trade-off, right? And that's why you have to be, that's why the partnership with the data scientists and the engineering team is key for this. So now let's go into more details about, okay, let's go again into this ML cycle, and what is the role of a product manager in this cycle. To formulate the problem, how do you think that this is, like, how involved product manager should be here?
Very involved.
Yeah, super involved, right? This is where you fit. What is the problem? What is the measurable goal? What do you want to predict? And there are very different ways that you can do this. I'm going to go through two different examples. When you have not used ML before, and maybe when you have used ML before, like think about like when optimization versus just launching something. So you going through the similar problem that we discussed about the sellers, which ones are the successful sellers that are getting into Amazon, like how would you define the problem? So one way to define it is that so say each week the new seller success team onboards hundreds of new sellers, and this group is expected to grow X% year by year. Personalized coaching time, however, doesn't scale. As such, the team needed a way to accurately predict top performers to double down on. So that's a good problem, right? You say, yeah, this is, we can scale this. This is going to keep growing. We need a way to do this in a better way. And as you know, things will keep changing, right? Like the problem is, like if you just use some like certain specific variables, you may not be able to use them like a year from now. So that's the problem. So what will be the goal? Any takers?
90% precision.
That's the goal for the model.
Isn't it good to establish what is an acceptable precision at this stage? Or do you talk about that later?
It's part of it. I think that here you're trying to define the problem. So what will be the goal to know that you're doing well? Because you can have a model that is 90% precision, right? Is it solving that problem?
Does the sellers that they actually pick end up being successful?
Yeah. I mean, it's basically, are you like you want, like, the goal is actually to increase the revenue, right, of the coach versus notch coach by X%. So you have a very specific business goal. This This is very business problem. Like what do you want to know? Like you have this problem, and the problem is that the sellers you have limited resources. That you need to identify these sellers. You want to coach them, and if you coach them based on this model, they're supposed to get better, right? So the goal is like, are these the ones that we're coaching? Are they getting better? Because you actually don't know which are the. You don't really have. How can I say this? You're predicting if they're going to be good sellers or not. So you don't actually have a sense of saying, these are the good sellers, and these are the bad sellers, and these are the ones that we chose. You don't really know which are the best sellers. This is your best guess. So your best guess is to say, from the one that we chose, that we believe that are the best one, they should do much better.
Would you have something else to figure out that you actually pick the right sellers but not the right coaches?
Oh, that's another way. Yeah. I mean, that's a different. That's a different problem. I guess that at this moment you may, for example, this will be what I would do, right? You have your team, you have like 5 people that are coaching 5 teams, and their success rate with the way that you were choosing them is like they increase revenues by 10%. So if it's the same people that is doing it, it's just the seller that you're choosing, you're expecting that you're choosing better sellers. So then with the coaching, it should be better than 10%, right? So what do you want to predict, right? So in this case, it's like the top 5% net sellers. So that's what you actually want. What are the net sellers? And then the goal is actually the revenue, right? But the prediction is which one are the sellers. So that's something that, for example, you never use machine learning, and you can use from scratch. Another problem that you can use for machine learning, and this is something that I used, is, for example, the problem is the units per order for specific category at Amazon in the US has remained flat. That means that it hasn't grown. And engagement has declined as measured by this other metric. That's that's a problem in the business sense. Maybe you don't have here all the details, but you're like, well, we're investing so much, we have more products, but this category is just not going up. So it's a problem. We wanna, you say, yeah, that's a problem. You're not thinking about the solution, you're not thinking about anything. This is just a problem. But what we want in this case, or what the team wanted, is to increase the unit order rate for this specific category in the US by X% within the next X months without affecting revenue. So then you're starting to put in limits, right? You have, well, this category hasn't grown a lot, and we will expect this to go. So I want more people to order more products. But for example, something interesting here is to say, suppose that your number of items per order are 5. I want it to be 6. And the issue, why you want to be 6, there are multiple business reasons, right? Why you want to be 6. Just trust me that it's good that it's 6 and not 5. But you don't want them to spend less money. So you're also putting some kind of boundaries to say that will be my goal. And what do you want to predict? It's well, actually, the solution here is about recommendations. We want to recommend you the next product to buy. So what you want to predict is what is the most likely item that people may want to buy when they already have something in their basket. So as you see, it's important to understand the difference about what are you actually predicting, that is not exactly nothing about this is actually in the problem, right? Try to be very good at making sure that you understand the problem, making sure that you understand what is your goal, and not even think about machine learning at that moment, right? And then you're okay, with machine learning, what kind of prediction I can do so I can create a solution to do it? But this is a problem. The next one is to selecting our pre-processing data. So what do you think that is the role of a product manager here? It's actually pretty high. So in this one, you have to be really in the weeds, because if you don't have this right, everything will be wrong. So you need to make sure that you're like whatever data set that you're using are good ones. From where are they coming? Is the data are the right data sets that you're using, and are you using it for the right purposes, right? I say that you have to have selecting data to train the model, to test the model. Do you have enough about that? What happens if you, for some reason, some of the data is you missed it? Do you have enough to replace it? Do you have to go? I mean, if think about the process that you have to gather that data, and suppose that you go through that process and suddenly you realize that you don't have enough. Do you have to go again to gather more data, and it's going to basically delay everything? So think about all of that as a product manager. Like, how are you getting the data? Do you have enough data? Do you have enough data to measure success? And in formatting, you don't actually, like as a product manager, you don't really do much. I mean, I'm not going to go into these details, but basically you have to make sure that everything is in the same format. Just be involved to make sure that you're not doing, like something is not going completely wrong. But this is pretty simple. In terms of like removing or fixing missing data, you do have to be a little bit more involved, because then you will start trying to figure out like, well, is this the data that I told you what data set, I told you what to do, but then really go and review the data and look at the data sets and actually go and see, is it incomplete? Like, is it noisy? A good example of noisy is, again, like if you are, for example, if you are doing something with orders and you have an order that is, I don't know, like $50,000, like you don't want to use kind of that data to predict your model, because it passes threshold. So making sure that it's not noisy, that is not biased or inconsistent. Pay attention. Actually review the data. I always went with my data scientists and say, okay, let me see the database, and send it to me, and I will start looking and making sure that things were fine. And there are many ways to do this, and many ways to, like, if you find problems, there are ways that, depending on the specific problem, sometimes you have to say, you know what, we have to delete this data. Like some of the data, even after you selected everything, you say, no, this data it's going to bias the model. Let's delete it, right? And that's what I was telling you. It's a difficult decision, but you need to make sure that you can take it if that's the right one. Other time you say, you know what, yeah, it's not perfect, but like you just say, well, you can just substitute some of the data. It's pretty easy, right? Like you can say, in this case, if the price was empty, like of course, it's empty that value, but it's zero, right? So it's very easy. There are other ways that you can say, well, when you don't have the data about everything, can you just like do an average substitution so you can actually use it? That's also something that, depending on the problem, depending on the data, you may want to do. And the engineers or the data scientists are going to ask you as a product manager, like, what should I do? Like, we have all these issues with the data. Should we delete it? Should we do a substitution? Should we put dummy data? Should we like just put whatever is most frequent? Should we try to actually find like what is the actual parts of the data? Do we have another database that we can relate to and gather that data? So in that one, you have to be involved, because all of those decisions are very, very relevant for your project. Then you have to also choose representative data. There are many ways to do it. You can use just random data, and there are pros and cons to do that, because if you choose random data, for example, for all your customers, it's possible that you don't get a customer segment that you are interested to gather. Or you can do stratify, that you can say, for all my customer segments, I'm going to get like specific data. All of those has pros and cons. because if you use random, you may be missing some kind of segment. If you use stratified and the segments are not well, some of the segments are like, if your segmentation is incorrect, you can also either double counting or have some problems. So there are tons of issues, seasonality, that if your data we were discussing, if you only use for a specific time, that the data is not great. If there's a specific trend that you're not catching, or you only caught the data with that trend. Leakage will mean that some of the data will actually start getting back into your model. An example is sometimes we're using some machine learning models to solve a specific problem because another machine learning model was not good, but then this machine learning model is helping this other machine learning model, and suddenly they say, oh, this machine learning model is not good. And you're like, no, actually this one fixed the issue and helped this one, and without this one, this wouldn't have helped. So you really need to understand how you're getting your data. We don't have a lot of time. We have only like a couple of minutes. So the main part that I want just to talk to you is that really think about biases here. I don't know if you, I guess that everyone has heard about the fiasco at Google when they were doing labeling of images, and they were labeling gorillas for people of African American descent. So, and that was because their data was biased, right? Like they didn't use representative, and that's wrong, like really, really wrong. And the other, like something also interesting that it has like unintended consequences. This was something that happened at Amazon with free Prime same day, where they wanted to figure out like where should we have this service. So they were looking at past orders to say, well, these are where people are buying things. So these are the neighborhoods where we're going to allow this service. And that's scalable because they can use the same model in every part of the world. What happened is that specifically for Boston, New York, many of the big cities, what it ended happening is that it was very racial. Like basically they say, oh, this is where we're going to be putting all of our free Prime day. But we're not going to use this one because people are not buying enough from here. That it makes complete sense. It just happened that most of this neighborhood it was black residents, right? So, and it was in the middle of the city. So like, why you're not providing your service in the middle of the city? And they're like, well, the machine learning model said that they are not going to buy, right? But not because you have a machine learning model that is telling you what to do, that means that you have to follow. So as a product manager, you really need to understand, right? So there are tons of biases. There are tons of, I'm sorry, like we don't have enough time. There are a lot of ways to actually reduce those biases in terms of labeling. There are a lot of techniques. Sorry, I don't have time to go through feature engineering, but the good part is like you don't really need to be really involved in feature engineering. That's the part where the data scientists go. And there are many ways to evaluate different models. The data scientists will be going into that. When you have regression, you can go like root mean square error. When you have classification, you can figure out if it's accurate or not. This is where the precision and recall items come. We're not going to go into that, but you can read anywhere online about it. The main concept here is that you're making predictions, so you really need to figure out if the model that you want to do want to optimize for precision or recall. Precision is basically what proportion of the identification was actually correct. And in some cases, that's what you want to that's what you want to do. Like this will be very good, like for recommendations or personalization. Like mostly, I want to recommend something that is good. If I miss here and there, not bad. Recall is like you really want to make sure that whatever you're saying is correct. So this is mostly like the classic is like, oh, there's a fire alarm. You want to make sure that every time that there's a fire, you actually predict that there's a fire. And there's some trade-offs that you have to do. So I don't know that we are going to have time to do this, but the main I will just go with the takeaways. Treat your ML project as a partner. Engineers, data scientists, business, everyone. It's very important that everyone understand like why you're doing what you're doing and why data is important and why selecting data is important, why biases are important. People need to understand that. Be very clear with your problem, hypothesis, and success metric. Again, think about the problem, the customer problem that you want to solve. The solution could be like multiple, right? Don't start thinking about like what prediction I want to do, like what problem do you want to solve, and is machine learning the right one? And be willing to make a lot of trade-offs in terms of time, in terms of quality, prediction, accuracy. I would say white box, black box, like do you want to really understand all of the details that are happening or not? I would say false positive, false negative, like recall and precision, and really to figure out like why are we launching this? The part is just when you're getting the data, make sure that people understand what the data means. Make sure that you understand scientists are not software engineers. Machine learning creates that. And be considerate, right? When you're working with people with different skills and what you bring to the table, right? You bring to the table this overall understanding. You're trying to get people, like they are the scientists. They know which algorithm is the best one, but they need to understand from you, like what do you want? Why do you want it? What problem do you need? What data do you need? Is this data the right thing? But if you start saying, oh, then use K-cluster instead of using this auto model, you're crossing the boundary and you won't be liked. And that's it.
We have a little bit of time left, so at this point I can only take 5 questions from you. Yeah.
Cool.
So do you think it makes sense to conduct some great experiment on the machine learning feature? Like, I'd like to know if it works or if I should do something else with the RL feature work.
Yeah. What do you mean, like if it's worth to do an experiment after doing the machine learning, or? Yeah, I mean, I would say that at least in my world, I've never had launched anything without an experiment. But that's, again, that's the benefit of working for a humongous company. Yeah.
So in your case, you said in the initial part, which problems do you want to choose to do ML or not?
Yeah.
I know, some problems you put it into production and then you realize, oh shit, it has a lot of bias.
Yeah.
But what were the problems that you thought machine learning was good for and immediately killed it? And vice versa. Problems that you thought that machine learning is not good for and later on invented did machine learning.
But at the beginning, I thought that machine learning was not good for, and then I decided that I should do machine learning after.
And then the opposite.
I have to say that most of the times, the issue is not so much that the machine learning is not good. It's like there's something that is missing, right? So either the data is not great, or we don't have access to the data, or it's very, very costly to do it. So at some point, in many times I would say, this is not the right time to do machine learning. But then there was something like that change to say, oh, remember that problem? This barrier is gone. So then we can use it. But I think that has been my experience, that suddenly, for example, we had better processes. So then creating a new model was cheaper. So then suddenly, like the threshold to how much money do you need to make was lower. So then it's like, oh, now it makes sense.
How about the opposite?
That we did machine learning and then we decided not to do it. Actually, I've never had that situation because we, specifically for me, I think I had always been very, very careful about what I put my engineers to work on. So I just haven't had that issue personally.
What are some of the techniques you have used to eradicate the bias in the data? Like did you generate data?
Yeah. Some of the things that I would come is like I do almost a brainstorming session with people and say, find holes, like find problems. This is what we have. Like sometimes the issue, like I am biased. Every one of us are biased. So I may not see some problems. So then for me, it was always like, this is what I'm doing, what do you think? And I will go with different types of people, different roles. People, something that I will always do is like go with someone who is completely, who couldn't care less if this project launches or not. Because there's not, they are the one who will say, yeah, this doesn't make sense, so don't do it.
What was the prominence of deep learning in that project? So you didn't have to use that much deep learning.
Yeah, I never did deep learning. Like, I mean, myself. The team did it, but I just didn't. I don't have experience on that.
Basically, you could solve all those tasks without requiring deep learning models.
You could. The main problem with deep learning is the compute power. It's very expensive. So at the moment when I was at Amazon, it was too expensive for my team. There were other teams that were doing some explorations. So when I left, there were some exploration, but I didn't participate on that. It's just the fact that it was expensive.
So I've got a question about PM's role with sampling and cleansing.
Yeah.
So I imagine it's kind of a fine line when you're working with like data scientists, be like, hey, I want to see exactly how you cleanse this data. I want to look at it. Like, how do you balance that so you're not like micromanaging? Really like questioning everything they're doing.
For me, it's more about like, can I help you? Right? I just I wanna make sure that you're not doing this by yourself, right? Like, do you need a second pair of eyes? And usually people are very perceptive to say, oh I don't know, right? So if you want to help, go ahead, right?
In one of your last slides, you said that machine learning generates tech debt. Can you elaborate on that?
Yeah. So if you have any kind of model, right, you're discussing like you have a specific database where you're storing the data, and you have to create a pipeline to basically generate the data and put it there, look at it again, make a prediction. So you need to really understand, like, is it worth it? Like, because someone will need to maintain that. And then if you create a model and it gets out of date, then like you need maintenance. So think about that. Sorry.
Yeah, my question is, as a PM, do you make decisions based on the data, or do you make it based on the objective of the project?
I mean, you start with the problem, right? Like with the customer problem that you want to solve. And then when you start trying to figure out what are the potential solutions, you may think about machine learning is a potential solution, and then you start looking into the data. But you start with the problem.
In the last talk where you said that like the same day delivery problem, and then there was like that feature of like the demographics of that population probably didn't exist in your input data set.
No.
So like, how do you, I mean, is that just something that like you just have to add more data and you just find?
So I think that was a Bloomer investigation that did this, and they basically when they asked Amazon, like, hey, you completely excluded this population, and they're like, we didn't use like even like we didn't use any race to make this thing. He's like, no, you didn't, but you still make that prediction. So I think that you as a product manager, you really need to figure out like, what could I be doing wrong? Like, what can this data, how can this go wrong? And the larger the company that you work for, the more careful that you have to be.
Can you elaborate on any insights that you might have? You mentioned kind of using unsupervised learning to define customer segments.
Yeah.
And so I was kind of curious about your experiences there.
So I didn't use it for customer segments. I used unsupervised learning for doing a lot of clustering, specifically, but not for customer segments.
Okay.
Yeah.
But in terms of customer segments, like what would you?
Oh, yeah. So you will use behavior, like what kind of. So for example, it's the way that I will, and I still think about customer segmentation. I think about either your intent, your mission, your behavior. That's how I think about customer segments. I don't think about customer segments about like what's your role, where do you live. No, like.
Which soft skills do you think are most important or come to play a lot when you're dealing with this? Especially because ML is so hot right now everywhere,
Yeah.
so you want to be using it.
Yeah.
And that's where executives or business segment would be very interested in seeing. So it seems like you would want to say no a lot.
Yes.
So yeah, soft skills for PMs.
Yeah, I mean, that's great. And I think that for me, the most important skill for a PM overall, not just for machine learning, is empathy. And what I'm talking about empathy is that when you're talking with the different stakeholders, you really understand what's their problem, like what are the pressures or the stress that they have, what they want to do. So then you can really empathize about like why are they pushing this so hard, right? Like if you're talking with some of the, and I've talked to many marketing people who would say, oh, this is what we want to do. And I'm like, it doesn't make any sense. But then I'm like, why? Why do you want to do that? And then I understand that, well, we have this other business goal. And I'm like, oh, okay, I can help you with that, right? So really trying to go deeper, not judge people. And the other part that I want to say is, don't be condescending. Please don't be condescending. Like when you are talking to so many people who have never been in this field before, or like just don't say, oh, you don't understand anything. Like you didn't understand anything in like a couple of weeks before, right? So be like understand, like try to put yourself in others try to empathize and make sure that you understand what the problem is. And saying, yeah, I want to solve the problem. We can figure out what solution to do. Yeah.
So just to follow on to that, and how about to the development team who really wants to be working
Oh,
on ML now?
that's a little bit more difficult. And I think that it's about like let's try to figure out like together like what information do we have, like what do we want to do, and really I think that for me was like really involving them to say this is the problem that we have. Do you want to explore that solution? And at some point I did have to do that, like to say, okay, this person really wants to do ML with this. It's like, okay, let's do a blog and do 2 weeks and figure out if you have the right data to do it. And then they will come and say, oh no, it's not actually good. Yeah.
So do you have any specifics like any learning resources that you can say that to start learning about this and try out something, any structured way of looking at things, these things, like this machine learning? Any learning resources that you
learning resources. Good. So now that I'm at Google, I will plug this. I mean, one of the reasons why I actually changed is because Google actually had like really great resources if you are working for a smaller company to actually use a lot of their machine learning and auto ML. That a good example that I wanna like. I think that if you go through the Google website, you will understand a lot of that. But something that is super cool is that we're talking a lot about like identification of images and classification. It's like how do I do that? Like how do I know that an image is an orange or an apple? Like what the hell? Like yeah, I understand the concept of labeling this data, but how do I do it systematically, right? So like right now with Google Cloud, with AutoML and Vision API, you can just connect to that, get the data, label it. So I don't know. That's a good resource to start.
Okay.
Should we? One more.
Yeah, you mentioned machine learning lifecycle. Could you talk about the timeline? Normally, how long is for each phase? How long do you dedicate each phase?
It varies a lot, of course, as everything. I would say that the one that you have to pay the most effort is in the problem statement. Just making sure that everyone is aligning. When you have the problems statement, you as a product manager, you're focusing on that one. You kind of have an idea of the data, but let's put it in this way. You're not going to, well, maybe with the new Google AutoML, you can do it very fast. But if you're not doing some of those tools, you're taking months, right? You're not taking weeks. This is a month, if not like year-long process. Some of the machine learning models need to be constantly iterated. You may not have thought about some things. So think long-term for many of these processes. As I said before, you are investing a lot of resources. This is expensive, and you're doing it because it's something that is going to scale and is going to be helpful like long-term.